All right, welcome to this explainer. Today, we are unpacking a massive, and I mean massive, paradigm shift that's happening right now in the software world. We're actively moving away from static, rigid workflows and stepping into the era of dynamic, thinking, agentic systems. We're talking about using incredibly powerful environments like anti-gravity paired with models like Claude Code. Listen, if you've been paying any attention to the tech space lately, you already know that the way we build applications and automations has been completely turned on its head. You can literally build full AI systems in minutes now instead of hours.
So, here is our roadmap for today. First, we'll cover the shift to Agentic OS. Then we'll break down exactly what model context protocols are. After that, we'll walk through the BLAST building framework, talk about how to make your AI logic actually reliable, and finally, we'll get into deploying your full stack apps. Let's get right into it.
Starting off with Section 1, the shift to Agentic OS, which really is a total paradigm shift.
Not too long ago, traditional workflow builders totally dominated the landscape. You had to construct every single scenario node by node. For example, if you got a new lead in your CRM, you had to set a super strict static rule just to update an email. But an Agentic OS fundamentally changes this entire process. There is a stark contrast between rigidly gluing those steps together in older systems like NN or Zapier and unleashing dynamic AI agents that actually think and adapt. Instead of being stuck with a single agent bottleneck, you can now have 5, 6, or even 7 parallel agents working independently on different tasks for you at the exact same time. It doesn't just blindly move data from point A to point B anymore. It actively thinks about it.
So instead of building a scenario step by step, it's basically like you're hiring the smartest intern on the planet. You now have this 500 IQ co-pilot that knows your business inside and out. But, well, here's the catch. Even a genius intern is completely useless if they're locked in a dark room without a laptop or an internet connection, right? They absolutely need to be given the right tools and the right context to actually succeed.
Which brings us perfectly to Section 2, Model Context Protocol Explained, or Universal Connectivity.
To get that intern online, we use what's called a Model Context Protocol, or MCP. Think of an MCP as a universal remote control. It is the crucial bridge between your AI's brain and your actual everyday business software. It's what takes that superpowered AI and wires it into the real world. Without an MCP, your AI is totally isolated. But with it, the agent can reach over, read data, and execute actions autonomously in your favorite platforms. And you don't even have to write complex integration code from scratch. It's a total game changer.
And this connectivity goes incredibly wide. By just utilizing API keys to create secure handshakes with these platforms, your AI can do some amazing things. It can automatically pull meeting transcripts from fireflies.ai, extract the action items, and then create beautifully formatted updates directly in your Notion database. It can query a Superbase backend or even scrape Reddit for viral trends. But pro tip here, there is a golden rule you absolutely have to remember. Keep your connected tools under 50. If you activate too many tools at once, you're going to overwhelm the AI's context window and really start confusing its memory.
Now let's move on to Section 3, the BLAST building framework. These are the 5 steps to automation.
To make sure our genius agents stay on track and don't get lost, we use the BLAST framework. It's a foolproof 5-step system for creating deterministic, self-healing automations. Whenever you want to build a full-stack application or an intelligent dashboard in an environment like anti-gravity, you just run through these exact 5 stages: blueprint, links, architect, stylize, and trigger. Following this guarantees you won't miss crucial steps that would otherwise cause your app to just fall apart like a cheap suitcase the second a user touches it.
Step 1 is the blueprint phase. And listen, before you touch any code whatsoever, this phase demands that you answer 5 specific questions in plain English to lock in your vision and logic. Because honestly, the problem we are solving is way more important than how we actually solve it. So you need to define the North Star. What is the ultimate desired outcome? Then, list the integrations you need, like Notion or Fireflies. Define your source of truth. Maybe that's a Superbase database. Establish the delivery payload, which just means where the final result is going. And finally, set the behavioral rules. By feeding all of this into the AI up front, you steer it perfectly from day one.
Once your vision is locked in, you move to the links phase. This is all about progressively connecting those MCPs and validating those API handshakes with external databases and tools. But while you're building, you have to actively manage something developers call context rot. See, LLMs had massive context windows, but by the time you hit the second half of that token limit, the AI gets tired. It's kind of like how you'd feel if you hadn't eaten for 6 hours. It literally starts hallucinating. The fix for this is surprisingly simple, though. Just open a fresh chat window to refresh the context and keep your AI performing at its absolute peak.
All right, Section 4, making AI logic reliable, ensuring everything works exactly as expected.
This right here is the absolute core challenge of agentic systems. We have to force naturally unpredictable, probabilistic AI models to act with strict, machine-like, deterministic reliability. By their very nature, LLMs are probabilistic next-word prediction tools. If you ask them the exact same question 100 times, you might get 100 slightly different answers. But obviously, if you are building an app for clients or managing a strict business database, you can't have that. You need the exact same flawless result every single time.
So how do we fix that? We enforce deterministic behavior during the architect phase by separating the system into a strict three-layer architecture. First is architecture, which involves writing out technical standard operating procedures or SOPs, defining logic and edge cases. Second is navigation, which is a routing layer that just moves data between tools without overthinking it. And third is tools, which are the actual deterministic Python scripts executing the actions. This creates a golden rule that you must follow. If your business logic changes, you have to update the written SOP first before you ever update the code. The SOP is your absolute gold standard. Functionality is obviously critical, but we all know first impressions matter immensely. So before we launch, the stylized phase ensures your app isn't just functional, but gorgeous. And my favorite pro tip here is a technique called UI sniping. Instead of asking the AI to invent a whole design from scratch, you just go to component libraries like 21st or CodePen, find a stunning CHAM interface or a button layout you love, grab that code snippet and feed it directly to the AI. Tell it to adapt that beautiful, pre-built component to your app. You can even do this in tools like Notion by commanding the AI to use specific emojis, headers, and callout blocks, so the data is super engaging and easy to read.
Finally, we reach Section 5, deploying full-stack apps, taking this from your local machine to the live web.
So your project is going to mature in 3 distinct stages. It almost always starts out safely on your local host that's running directly on your laptop while you test and refine it. From there, you'll likely move background automation tasks to a platform like Modal. And then finally, when you want the world or your clients to actually interact with the front-end interface, you publish it live on a hosting platform like Vercel. And the crazy part? You can do that with just a simple command to your AI agent.
A massive part of this deployment relies on the final step of the BLAST framework, the trigger phase. Because look, running an AI agent on your laptop is great, but what if you're at the gym or you're sleeping and you want your system to scrape Reddit for viral trends or pull meeting notes every 3 hours? Using platforms like Modal allows your agent to work completely autonomously in the background. You just deploy the function, set a strict schedule, and it executes flawlessly without your laptop ever needing to be open.
Now, let's be practical for a second. With all this talk of AI agents replacing workflow builders, I want to clarify something. Traditional builders like N8N or Make aren't completely dead. Not at all. They actually remain incredibly useful for strictly deterministic, highly complex step-by-step tasks. If you have a massive workflow where a user submits a form and it triggers 20 cascading business logic steps, having a visual canvas where you can easily spot exactly which node failed on a Tuesday at 2 p.m., that makes granular visual error debugging a whole lot easier.
We have covered a massive amount of ground today, from the universal connectivity of model context protocols to the structured, self-healing reliability of the BLAST framework. You now have the exact blueprint for wielding these powerful agentic AI systems. So the only limitation truly is your own imagination. If you had a 500 IQ copilot armed with a universal remote to all your apps, what full-stack system would you build first? Keep learning, keep building, and thank you for joining me for this explainer.